Afternoon, everybody. Expected. Assembled. Afternoon, to all of you. Madam, my name is Ognimitra, and I am currently position of IdeasTI. So, what is ideas awareness and what is ideas? That's what. And I will theme of seminar which and sustain. Ideas is actually an acronym, stands so that IIT. What is a technology hub? As you can see, my slide founded funded by DST Department of Science and Technology. So Department of Science and Technology started a Department of Science and Technology 20 National or Interdisciplinary CyberPhysical Systems NMICPS. Okay, so this is a very high level, very important that the government of India has launched. The objective of this is self-reliable. There's a broad range of technologies. Okay, so interdisciplinary cyber physical system, it covers a broad range of technology, mostly the what we call the deep tech technology, that is artificial intelligence, machine learning, data analytics, robotics, all that comes under ICPS. So this mission was formed in 2020 with 4,000 crores, and it's governed directly by Prime Minister's office. And they want to check, how India is progressing innovation technology area. Because most of the technology that we hear about is, originated outside. IIT Kharagpur has a TIH. IIT Guwahati has a in Eastern India. If I talk among the non-IITs, you will find the TIH in ISI Kolkata, Indian Statistical Institute. We also have one in IISc Bangalore. There is one in IISER Pune. Can we settle down, please? Lot of talks. Excuse me. Can you discuss outside? If you have something urgent, can you discuss outside, please? Yeah. Need a lot of attention, especially from the student community, because what I'm going to discuss is nothing related to theory or theoretical studies or papers. It's about the opportunities that are available in this TIH. And not only the TIH in ISI Kolkata, but the TIH all across the country. As I said, there are 25 TIH. So go to the web, search with any TIH. Suppose you say IIT Delhi TIH, right? So you'll find the website of IIT Delhi TIH. If you go and search with IIT Kharagpur TIH, you will find the IIT Kharagpur TIH. All the TIH have the same mandate, that is technology development, skill development, and startup development. Now each TIH has been given a particular area to work with, okay? So these are the verticals. So ICPS covers a broad range of technology, as I said. Now each of the TIH has been given one technology area to look into. So IIT Kharagpur is, for example, the TIH for AIML, Artificial Intelligence and Machine Learning for Cyber Physical System. IIT Kanpur TIH is for cyber security. IIT Madras IIH is focusing on sensor and actuators. Okay. IIT Guwahati is focusing on underwater technology development. So each TIH has been given one area to look into. IIT Bombay TIH is focusing on IoT, Internet of Things, right? So ISI TIH focus is data analytics, right? So we do data science, big data analytics, data curation, data engineering. These are the focus of the TIH that has been formed in the ISI Kolkata. And, in terms of, there are few other things that I would discuss. So let's talk about briefly about what is cyber physical system. Why is this name interdisciplinary cyber physical system coming into? And how is it different from the other technologies? It's not really different. See, the way the world is moving, as you know, our virtual world, which is the world of internet, which is the world of cloud, which is the world of digital. Now, the virtual world and the physical world are the buildings, the machinery, and the tangible things, the automobiles. You know, these are the physical world. Now, the virtual world and physical world are now integrated, right? Earlier, more or less, they were separate. There was not much integration between these two worlds. Now, as the technology is progressing, due to the advent of communication technology, due to the advent of cloud-based technologies, cloud-based storage, cloud processing, you know, servers in the cloud. So what is happening is there is a lot of real-time data interchange between the physical systems and the virtual system that is the cloud-based. So how the data is getting moved from one space to another? So first of all, there has to be some kind of a sensors, right, to capture that data. So as you know, in a car, all the modern cars, I'm not talking about e-vehicles, I'm talking about our regular vehicles. Each of our regular vehicles has a mini computer, right? It has a, you know, hundreds of sensors inside the car. You know, somebody checking the speed, something checking the fuel, some sensor is checking the temperature, some sensor is checking, you know, so many other things. And this data from the sensors are going into the onboard computer inside your car, and that onboard computer is deciding to give you certain messages from the dashboard, right? Now, this is still not an example of cyber physical system because the data that is generated by these sensors remain inside the car only. It is not shared with outside. But in the new age cars, many of these cars have navigation systems, which is an example of a cyber physical system, right? The car's navigation system is connected to the satellite. So the data from the car, the sensors is going into the satellite. It is able to do a positioning, and then you can track the car by using your mobile phone somewhere, right? So that is an example of a cyber physical system. So the sensor, the data is getting transmitted to a cloud, to the virtual world, and then from the virtual world, it is again getting read by another device through which you are making some decisions or actions. So a cyber physical system needs to have these components. One component is for the data capturing, right? So the data needs to be collected. It could be in an industrial situation, the industrial automation, the PLC-based systems, you know, they capture a lot of data. That data needs to be processed and sent to the cloud, to the virtual world. So that can be by using different kind of communication technology. Now, if it is a data which is only, for example, shared with your smart watch, right? You are wearing a smart watch which is measuring your pulse rate, and that data is coming, you know, probably to your, you can track that from your computer if that data is transported. So your smartwatch is probably using Bluetooth, right? Or it can use a Wi-Fi, or if it is a wide area network, it can use a WAN. If it is a, or it can use a LoRa, right? Long range communication. So different kind of communication technology is helping the data to be transmitted to the virtual world. Then there needs to be a control component. You all know, you are engineers, that what is a control system, right? Control system means by taking an input, You have to track it against a measured output and then make some decisions what needs to be done, right? So in an autonomous car, the control system has to decide whether the car needs to go right or left or increase speed or apply your brakes, etc. That is the whole control mechanism, right? If it is an, say for example, you are creating an autonomous system for irrigation, right? So there are IoT devices from where you collect the soil information, you collect the atmosphere rig data, rainfall, temperature, etc. that goes into a cloud-based system, and then there has to be a control mechanism which decides, okay, if the plants are dry, then you switch on the the drizzler so that there is enough water is getting poured onto the plants or something like that. Or if the soil nutrient is low, then you inject some nutritional components into the soil. I'm just giving a very broad example, but this control mechanism decides how the cyber world will interact with the physical world and what kind of decision the physical world is going to take place. And finally, there has to be an interface with the human. There has to be a way to see how these two worlds are interacting, right? Either it will be a web-based application, mobile application, a smartwatch, smartphone, any of those that needs to be built in. So as you can imagine, this covers a broad range of technologies, cyber physical world. As I said, starting from data acquisition, so data is the primary thing. Without data, none of this will work. Now, how is that data getting generated? You have the sensors and actuators. So one area is sensors. Then how the data is getting stored, communicated, so that requires your cloud-based technology. There is an issue of data security. Because you're storing the data in the public cloud, there has to be a security component, so cyber security. Then that data needs to be processed, so there comes data analytics. Now, if you are adding another layer of intelligence onto it, then it becomes machine learning or artificial intelligence. So all these different topics are broadly covered under ICPS. And as I said, ISI Kolkata TIH focuses on the pure data analysis, data analytics, data engineering, those parts. So those who want to learn a little bit more about what is this mission, I explained very briefly, but if you want to still go and find out, click on that link, right? Or just search in Google with NMICPS, National Mission for Interdisciplinary Cyber-Physical System. All right. Now, IdeasTI, as I already mentioned, IdeasTI is the Technology Innovation Hub at ISI Kolkata. And all of you know what ISI is. ISI has a long history of legacy in statistics. Many of you probably know that India's first computer was installed at ISI. India's first computer. Did anybody knew that? Maybe some of you know, right? So ISI has a very, very long history in technology, statistics, data science, data analytics, machine learning, computer vision, pattern recognition, cryptology. These are some of the areas of where ISI faculty and researchers have done a lot of work. So we want to bring that expertise now into the IdeasTI. So IdeasTI is not a department of ISI or a center of ISI. It is a separate Section 8 company which is governed by ISI. Why a separate Section 8 company? Because when you are a part of a university, there are a lot of limitations. There are less flexibility. You have to work under a university system, right? But when you are a separate company, then the company can make a lot of independent decisions, right? So this has been formed as a separate company, a Section 8 company. Section 8 means this is a not-for-profit organization. This company is led by me. I am the CEO of this company. I report to the board of directors. The board of directors consists of ISI director, ISI deputy director, and program director. Okay? So ISI is involved for the day-to-day functioning of this company, but at the same time, this company is working as an independent company. So, so what are the things that we are doing? So let's um, come to these goals and vision of the company. So as I said, there are three key, you can read through this, but there are three key things. One is technology development. Technology development means trying to come up with real technology, right? Because in India, the researchers mostly focus on fundamental research. If you go to the universities, they do the researcher publishes it in reputed journals, they get a PhD, and that's all. The research ends there, right? It doesn't get actually converted to something that we can see in the market. Because our market is flooded with Chinese technology, our market is flooded with American technology, our market is flooded with other technology. There are very few Indian companies who have developed a technology to capture the market. I'm not saying there are no examples, there are examples, but very few. So one area that we want to focus is technology development. So to give an example, suppose one ISI faculty has developed a research, a concept for which they have done a research, they have taken it to a certain level, say up to a proof of concept, right? So up to a proof of concept is done. Now, is that something that we can take and convert it to a technology by developing a software, developing an asset, developing a product, you know, converting it in actual physical product? Many things are possible. So develop the technology, take it to the market. So our mandate is also not only to develop the technology, but take it to the market. And for this, we are not only relying on the ISI faculty or professors. Actually, anybody who has an idea in the area of data science, data analytics, data engineering, data curation can submit a research proposal with us. We can assign a ISI mentor, but that is also not mandatory. So we have grants from ISI, DST to fund for this kind of technology development projects or researches, okay? But the key is that it has to be a translational research. What does translational research means? Translational research means the research is not only confined to the domain of research, but it can be translated into a technology development or a product development or an asset development, patents, and things like that, right? So that's the one key part. There are several other things. Now, any particular industry domain that we are looking for, there are some that we have defined. For example, smart agriculture, okay? Smart healthcare or health tech, right? Or smart camera-based systems, industry inspections, environment monitoring. So, as you know, the theme here also is sustainability. So, some of these innovations which are more related to the sustainable development goals or sustainability, those have priority, but that doesn't matter that these are the only things that you can submit your proposal. You can submit any proposal if it is a very interesting proposal where there is a huge potential to convert that research into a product. We are there for you, okay? So that is the message that I want to give. So what's in it for you? Okay, so a quick snapshot of what has been achieved here in the past 2 years. Frankly speaking, not much has been achieved. As you know, ISI being an organization in Kolkata, they have their own set of bureaucracy and inefficiencies. So they took a lot of time to actually understand how this IdeasTI Section 8 company is going to work. What will be the relationship with the parent organization, how it will work, how much funding is needed, who will run this, what kind of projects will do, etc. So it took some time, but now it is running in full phase. So far we are funding about 13 projects. We have 36 publications, but only 1 patent. So that is not a good number. In 2 years, we should have at least filed 10 patents, okay? Because our aim is to do translational research. That means it is a patentable technology. We have not done much. So in next 6 months, Department of Science and Technology is pushing ISI and pushing us that you need to come up with more patents, more technology development. So I am also under a lot of pressure from the DST to show results. They're saying this is nothing, compared to ISI's reputation, ISI's history. You guys have not done much, right? You have only come up with only few research topics. So we have to do a lot. We have the money, we don't have enough projects. That's the sad part of the story. And many researchers are looking for grants and funding, and they are not able to find that. So that's a very peculiar, in India only that happens. So DST has given a lot of funds to this 25 TIH, and nobody knows about that. They are looking for funds elsewhere. Okay? So that's the technology development. Then we are now looking for proposals. So if you go to our website, the website link is given in this. So just ideas-tih.org, that is our website. So go there, you will see that we are now calling for proposals for the next. So first group, we have received about 30 proposals, out of which we have granted 6 research projects. We are evaluating the remaining proposals. Maybe here also, we'll have, so you can see 7 here. 7 has been granted, 7 will obviously get, and then maybe another 4, 5. But we have already put up our call for the next cohort, next group of proposals. And for that, the deadline is 24th July. But 24th July, you don't need to submit the full proposal. Just submit your idea. Okay? And then if the idea is interesting, then we'll take it up. We also have a mandate of skill development. Skill development means conducting training, seminars, workshop. As I said, as I speak here, we are conducting a 5-day workshop on Earth observation data analytics. How do you get or analyze spatial data? And that's a huge application in construction and in many other industries. Satellite images, how that data is analyzed. Okay? There are hundreds of satellites roaming around the world. What are they used for? Not only communication. These satellites have the ability to generate data at a level of granularity of 1 square meter. So every square meter of the Earth's surface, you can get detailed data from the satellite, images. Data here means images. And then you can use those images to do a lot of analytics. For example, you can predict the crop health of a certain region by analyzing the image from the satellites. And that is not, you cannot probably make it in the naked eye. It needs a lot of data analytics, processing, etc. And sometimes it may also use machine learning methods and things like that. But that's a huge field. So we are having a 5-day workshop. Of course, I'm sure nobody knew about it in this group. The communication did not come. So first thing that we have to do is, we have to add elite college as a part of our communication network, so that you also start getting all these communications, what's happening, what's going on, etc. Right? So we will do a lot more workshops in data analytics, data science, and related areas. So those who are interested, maybe you can propose, Sudip sir can propose one data analytics for construction sector, right? I don't know, what kind of opportunities are there. We can co-host that with you. You organize a seminar, we can be a partner and co-host that. Things like that. So we have the mandate to do those kind of workshops as a part of our skill development. But the main part of skill development is fellowship, and I'll soon come to that. Okay. We also support startups, but the sad story is all these 3 startups that you see are outside West Bengal. We are not getting any proposals from West Bengal startups. Okay, so that's the sad part. No student here wants to do a startup. I think same story in Assam, right? In Kaziranga University also, we have an incubation center, entrepreneurship cell. No takers, right? So this is a big challenge area. So what is going to happen? Since there are no applications coming from Bengal, we are going to give the fund to companies that are applying from outside the West Bengal. Both these companies are Delhi companies, right? So they are taking the money, going away. Nobody from Kolkata, nobody from Bengal is applying, okay? So we want you to spread this information to everyone. So some of these ongoing projects, what we are running, This will give you an idea about the diverse nature of the projects that you can apply for. So don't get worried that, okay, my project idea is a very trivial idea, it will not work. It is nothing like that. Every idea has some value. If there is a value to translate it into a product, we'll certainly welcome it. So as you can see, there are here some projects from agriculture, smart health, smart agriculture, smart healthcare, generalized method to detect early oral cancer. So this is a generalized research, but it has to be converted to a product. Only after it has completed the POC, we have onboarded this project, not before it completed the POC. So if you just have an idea in your mind, that needs some kind of a validation, okay? Unvalidated ideas, we are not taking in as research proposals. Only where the idea is validated, you have some kind of results to show, some kind of a proof of concept has been developed. Those ideas is what we are taking, okay? Malware classification based on content. So various different kind of topics. So don't worry about which domain you are going to propose your project. We can accept projects from any domain. This is the infrastructure. So this is a dedicated space of about 3,000 square feet within ISI. Now the purpose of the infrastructure is mostly for the incubation center. That is the startups who want to incubate with us. Now, so this is the picture photo that you see, the incubation center. Right now we don't have anybody occupying this space. So it's all open, virgin space available to you. Anybody wants to do a startup, you need space, you need resources, you can apply to us and we'll see. So what are these opportunities? This is the main part of my presentation. And I want to leave this presentation with you. It is already there. I request Shrudeep sir to circulate it to all students and faculty. First one is the research proposal. Grant amount up to 50 lakhs. Okay. The PI needs to be very simple process. If you go to this page and click on the apply button, there is a Google form. Just fill up that Google form. There are 10 or 12 fields which talks about, what is your idea, what is the, is it a translatable idea, who are the possible competitors, what kind of product you can develop from these ideas, who would be your consumer, etc. Those kind of questionnaires. So once you fill it up, don't have to do anything else, and we need a cost estimate, of course, for the research work. So we'll go through those and those ideas so we'll do a first level of screening and the ideas that appeal to us, we'll call you for the project presentation. So this 24th July is just to submit the idea, okay? The final proposal, you still have time up to August if you are shortlisted, okay? So that is the first one. Next is for the students, Chanakya Fellowship. This is again, the name is government, DST's name. It is not something that we have coined. So DST has the Chanakya Fellowship, which all the TIH offers. So we will offer students a fellowship grant of 1,000 rupees, 10,000 rupees per month if you are interested to work in the area of data science, data analytics, data engineering, and data curation. So what you need to do, what I would suggest is form a group of students under a mentor, under a faculty mentor. So mentors from probably computer science department can pick 5 students, 5 bright minds who want to do something, form a group and then apply as a group. You can also apply as an individual, but the chances are that people will question is, as an individual, how much can you achieve, right? So rather, if you can apply as a group under a mentor, and the mentor has to make sure that you are doing your projects with all seriousness. The mentor has to make sure that you are submitting your project progress reports to us. So we will not do a very close monitoring of the projects, but we'll do a time to time, we'll have to check. Otherwise, if there is no check, then what will happen? We'll keep paying the students and no progress will be made, right? We don't want that. So fellowship, graduate internship fellowship is 10,000 per month. Are there postgraduate students here, MTechs? No. So these are not applicable, but for graduate student fellowship, you can apply, okay? Again, for details, go to that link. Next is for entrepreneurs. So first opportunity is Prayas. Prayas is for new entrepreneurs who have not yet formed their company, right, or startup, but they have some idea which they want to build on. So we can give a small amount of grant, like less than 5 lakh rupees, to develop a proof of concept, okay, in that area. So that's the Prayas. Again, all these terminologies, Prayas, etc., are DST's terminology. So every TIH you go, you will find this kind of terminology. Next is Entrepreneur in Residence program. So this is where the student, instead of working somewhere, they want to focus on entrepreneurship development. So we can recruit them as a part of our team. They will sit in our center. They will work on our projects as well as develop their own entrepreneurial ideas. And the fellowship amount is 30,000. Maximum is 30,000. Minimum is 10,000 per month. Okay? So that's the EIR program. Seed support system is for more matured startups, okay, where they have already formed the company, they have already developed the proof of concept, now you want to convert it to a product. So the funding for seed support is much higher. As I said, it can go up to 50 lakhs, but you have to enroll yourself as a part of our incubation center. Now, it need not be physically incubated. You can be a virtual incubator. That means you can do your work at your own organization, at your own office, and we will assign a mentor to you. The mentor will monitor your progress. And if you don't want any money, but you still want to get associated with our incubation center, right? You want to use our infrastructure, you want to use our faculty staff from ISI to mentor you, etc., you can apply for our incubation program as well. Any questions on these two slides? These two are the most important slides. This is fellowships. Yeah. If you have already developed a prototype, we'll give more weightage to that. If it is a very abstract, you may not get it may not get approved. As I said, it is not just a pure idea. So we'll see, depends on the merit of the idea. Some ideas, by just going through the ideas, we can determine. And we'll have external experts also to evaluate the idea. It is not only the ISI faculty. We have people from the industry. We will have venture capitalists. We'll have experts from other startups and incubation centers. They will evaluate the idea and see what kind of potential it has. It has to be related to our core area, that is data science, data analytics, big data analytics, data engineering, data curation. For example, if you give an idea of starting an e-commerce website, that is not acceptable. Okay, although it has a data, you might say that I am analyzing customers' data, but that's not what we want. We don't want a general purpose software and things like that. There has to be a very, very strong data analytics component in the proposal. Because otherwise DST will question us. Why are you giving money to this person? His project is not related to your area. And they are already questioning few of our projects. They're saying, this should actually go to IIT Bombay Hub because they are working on IoT. I mean, we have funded a couple of projects which are working on IoT, right? So they are saying, these are better aligned to other. But, those are just, they are saying, I mean, there is no hard and fast rule that this project has to be with another hub. But there has to be an alignment. Otherwise, it will get questioned. It's not for students. Yeah, after you have completed, you want to start working as a new, budding entrepreneur, so to say. So two ways you can do. Either you have your own space to work, you have your own team, you start working, you ask for some funding. That comes under Prayas. Otherwise, you can say that I want to be as an entrepreneur in residence, I want to use your opportunity for that. So you apply as an individual, you apply there, you work with us for 1 year in our center, and develop your own idea. So you have to come up with an idea. For any of these programs, either Prayas or SEED support or entrepreneur in residence, any of these, you have to come up with an idea that we can see the potential of. Last one is you have to register as a incubatee with us. Okay, so you want to be a virtual incubatee, that is you are working in your own place, or you want to use the physically, you are welcome to come and apply. Terms and conditions, since we don't have any incubatee, we are still developing that. So we'll let you know, but it will be very, very nominal. I mean, there won't be any terms. Come when we put money. If you need money, we'll give you money in exchange of equity. If you don't need money, then there is no equity. Then it is just using the space. And even the rent and all, we will see. Right now, I don't think there is any idea to take rents. Okay, another, in the education space, we are, apart from workshops, we are also we have launched a certification program in data science, data analytics. So you can find the details here. Okay, it's not very readable. So this is an evening course on data science. The faculty will be ISI faculty, Professor Malay Bhattacharya and Professor Pradhan. So they are the organization. There could be other faculty from ISI also teaching you. So it will run for 3 to 4 months, twice a week, evening 6 to 8 p.m. in ISI campus. So without enrolling in ISI, this gives an opportunity to get a certificate from ISI. Okay? So that's the best part of it. And if you go to this, you can download the course plan and see the details of the data science course. So this is a certificate course. This is the first course that we are launching. There will be more such courses of different duration, 1 week duration, 1 month duration, more than 1 month duration. So as and when there's a launch, we'll let you know. This is a paid course. This is a paid course. This is a paid course. So anybody can apply. Anybody can apply, but there is some criteria. I think it's mentioned. It's a training, hands-on, everything will be done at ISI. Everything is there. It's 58 hours. 58 hours lecture session, 6 hours project session. As I said, twice a week. And the charges is 30,000 plus GST. This PPT is already with you. So, and just go to this website, ideas-tih.org. Yeah. The website, if you go to the announcements, there is a link called announcements. Under that, you will see all these announcements. Education and projects, startups, everything. Okay, I'll finish here. Thank you very much for the time. And I wish I could stay longer and attend the book launch session. But as I said, we are also having this 5-day workshop. Today is the last day, and we have a panel discussion. I have to go and meet with the visitors, have lunch with them. So it's kind of a conflict, but I would love to come again if needed. If required, we can do a virtual session with more number of students, participants. If you want, we can have that as well. Okay? So, unless, are there any other questions? data, data is the challenge for all data and machine learning projects. Unless you have good data, the models will not work. So it's challenge. I mean, that's where the data curation comes, right? So give us a proposal that in your domain, you want to create a data bank, right? Which the other companies and people, in fact, we are getting a lot of proposals like that. So because good quality data is not available, you start collecting good quality of data, people will pay you for getting that data, for curated data. So we have to develop a mechanism to keep that, either by paying agencies who are actually capturing. Like yesterday, we are having a discussion with this company which is based in Delhi, Suharto Technology or something. So they are working on the satellite data. So they are buying the data from 5, 6 satellite companies, right, throughout the world. Some of those are, American, Russian, Spanish, all these companies, and then they are adding the data analytics layer and making that data available to even the government. I mean, government departments like NTPC is a big buyer of their data because they need those data to study, for setting up new plants and things like that. So data is a big challenge, and that's why it's also a big opportunity. So if you can create a repository, people will pay you to buy that data. And for your project, if you are not finding enough data, I don't know. I mean, you have to tell us if you are part of this project, you can use this fund to buy the data. That much I can tell you. I mean, there is no easy solution to it. Or there is a new domain coming in artificial intelligence called data. It's like you can simulate a lot of data where there is less data, synthetic data. So the synthetic data is a new term that has come in data analytics. Synthetic data means that is not a natural data. Data is not coming from the natural systems, but you are simulating that data synthetically. You are manufacturing that data, but that data is exactly like the real-time data, and it can be used to train the models. So you can see whether any opportunities there. There has to be data science, data analytics has to be a big component. As I said, domain can be anything. It can be construction domain related. But you have to say, how you are using data science, data analytics, big data to actually, coming up with something novel, some novel solution. Okay, thank you very much.
Thank you so much, sir. The presentation was really very informative. Now, I would request our Honorable Principal of ECE to give a little token of appreciation to sir on behalf of Elite College of Engineering. Moving forward, we are going to start our second session of the second day of our seminar, that is Technology, Innovation and Sustainability, Recent Trends. Now, I would like to hand over the microphone to Professor Shravanti Chakraborty for moderation. Please.
Hello. Hello.
afternoon, everyone. Myself, Srabanti Chakraborty, the moderator of this session. I would like to extend a very hearty and respectful welcome to all our respected dignitaries, the respected faculties, and did his MSc and PhD degree from the University of Calcutta, Physics, and postdoc from the very prestigious Massachusetts Institute of Technology, MIT, Cambridge, USA. Sir worked in close collaboration with the leading laboratories like Lincoln Laboratory, Milestone Hill Observatory, Earth Atmospheric, and Planetary Science Division of MIT, and many other well-recognized laboratories in India and abroad. Sir served as professor and head of the Department of Physics, University of Kalani, Dean of Research and head of the ECE Department, Techno India University, Pro Vice Chancellor of JIS University, and Director of Brainware University. Dr. Bhattacharya has published 32 textbooks for science and engineering students, 2 popular books for general readers, and over 400 research articles in reputed international journals. Under Dr. Bhattacharya's supervision, 24 scholars received their doctoral degree. Sir is a fellow of the Institute of Electronics and Telecommunication Engineers and member of many scientific organizations. India International Friendship Society awarded Dr. Bhattacharya the prestigious Shiksha Ratna Award and Certificate of Excellence for meritorious services, outstanding performance, and significant contribution to education. The International Institute of Success Awareness honored him with their globally recognized Glory of India Gold Medal for his outstanding contribution to the National Statue of India. Sir, we are really very much delighted to get you, and it's my privilege, it's our privilege to get you in this session. I humbly request you, sir, please take this dais. We are waiting with full of ebullience to listen to you, sir. Thank you, sir. Hello?
Thank you for the nice introduction. I got this opportunity because of your principal, Professor Bosak, computer engineering as well. So it's a subject where we can do something today and also in near future. In fact, globally, a lot of work is being done. That way I can use it and can speak loudly. Mainly the theoretical aspects of the electromagnetic wave, and people are largely confused whether there is a real existence of electromagnetic wave or not. And that's why they were from that period 1860 to at least 20 or 25 years, they were thinking about the existence of the electromagnetic wave, which was ultimately successfully experimentally shown by Hertz. You know that the unit of frequency, cycles per second, is an alternatively called Hertz. So Hertz was the scientist who first successfully developed the electromagnetic wave experimentally. It was an excellent contribution in the science, And from that time, the lot of works were being done in different parts of the globe on electromagnetic theory and its applications in different areas. Soon thereafter, many works were done, and out of those, as you find, the second person, Christian, who started his work. He was really not a scientist, he was a technician, but he had a serious interest on the subject, and ultimately he showed that if some objects are there, then in presence of the object, that can be identified by sending the electromagnetic signal. And here is the application started. So electromagnetic signal can be received by the object and it can be immediately identified. Then soon the third scientist, he was a British scientist, Watson Watt, he started his work and he applied the subject of radar, which was developed by Christian in principle. So the principle was developed by him, but the application was done by Watson Watt in that area. So these are the background. So if you just look at the history, some of the outlines of the history have shown 1886 to 1888, this time Hertz demonstrated the generation, reception, and scattering of electromagnetic waves. Then 1903, 1904, it was further developed and some successfully some experimental observations are established. In 1925, because during that period, if you go to the history of electronics, you can know that 1902 Fleming developed the diode valve. Diode means two electrodes, anode and cathode, and electrons emitted from the cathode will go towards the anode when a positive is applied to it. Now, in order to control the flow of electron, a third electrode was placed in between cathode and anode called grid. That can be used for controlling record the pulses and its characteristics by using PPI and RHI, plant position indicator and range indicator were there. Then in 1937, chain home radar system came, and after the Second World War, during the World War, this radar was used successfully, and in 1941, it was further developed by early warning, by improving the early warning system in the radar. Now, as far as the radar beams can be considered, it can be attenuated, can be reflected, and can be bent by the environment. The different variations and their natures have shown here. Then now, if you think about the electrons in the ionosphere is at a height of 60 kilometers from the Earth's surface during daytime in presence of the sun, and when sun disappears, the height extended to 90 kilometers. Now, if you send the radar beam vertically upwards to the ionosphere, then what will happen? That can be used as a target, and these electrons can scatter radio waves, which can be ultimately received. So we can think that a pressure is created, the strength of the echo received can be assumed that an electron pressure is occurring. So the principle that was developed by Christian is like that. From the antenna, you are sending the antenna. It's a dish type antenna. If it is larger in size, then it becomes convenient because it can receive the signal strength by a significant amount. So from this point, it is transmitting the energy, and when an obstruct is there, for example, a plane is there, the echo signal will come out and again received by the receiving antenna. So in short, this is the simple mechanism how it works. So in the form of a block diagram, we can think about the transmitter, then transmitter transmitting the signal from the antenna, and then the obstruct will reflect the echo signal which will be received by the receiver, and ultimately that can be displayed. Here is a simple radar diagram where transmitter, receiver are simultaneously working. They are trying to locate the position of the object, and ultimately through the receiver it will be received, and after processor finally it will come to the display. Here is a moving target indication radar. Some modifications have done. Just a block diagram is shown here. We are not going into the detailed technology. What happens if it is a fixed one, then the mechanism is simple. You can just send the pulse and the echo pulses will come out. But when the target is moving, then vertical height can be changed, and also its location can be changed. So the radar beam which is transmitted from the transmitting antenna will identify and will locate the position of the moving object. Thereby, the information extracting from those will be received by the receiving section. In case of pulse Doppler radar, the mechanism is rather simple, but it is a modified form today, where we can put the antenna system within a very limited time by using the robotic system. Actually, what happens is that if you set the azimuth and elevation to it, then the computerized system will immediately set the position of the antenna, and from the antenna the signal will be transmitted, and in due course the information will be received. All this together will take time less than 5 milliseconds. There is a frequency modulated continuous wave radar, and so if we consider the principle, then we can think about the distance determination. That is one of the important criteria. Then the direction, the elevation, and also the range. The distance can be obtained by using simple relation S equal to CT, because the signal is going to the object and echo is coming out. So if the forwarding time is T and returning time is T, then it will be 2T, the total time when the signal is received. Taking half of it, you can get the required time of the object, and then by using CT relation, you can identify the position. That means you can find out the range. The direction can be obtained actually in the angular, because sometimes the beam is transmitted in the form of angle. So angular determination of the target is determined by the reactivity of the antenna, and for that purpose the antenna is to be rotated. Accordingly the speed will be changed. Sometimes it is faster, sometimes slower, and ultimately the object can be determined. The direction can also be identified if it is in some inconvenience position, then some mechanism are to be applied, and the direction can be determined in that way. The elevation angle is important. It is the angle, as you know, between the horizontal plane and the line of sight measured by the vertical plane. This elevation angle is to be placed on the system, and immediately the antenna will take its position to identify the object. Similarly, the range resolution is another important factor, where the range is to be determined by considering the resolution itself. Actually, before transmitting the signal, what we have to do, it is to be vital. We have to identify some of the principal criteria of the radar system itself. Once it is set properly, then you can start to transmit the radar beam, the signal. It will move in all the directions or in any particular direction you like, and accordingly you can get the spectral pattern. Studying the spectral pattern and similar phenomena, some other phenomena, you can then confirm what is going to happen. Now make a final set and you can collect data which will be more or less accurate. Of course, it is to be filtered in your convenient time. Then as far as timing is concerned, because timing is important. For example, if you just want to receive the lightning discharge occurring at some place, then you can receive it at some simple type of antenna. For example, by using L antenna or S antenna, you can determine the height and all other things, related things. But in order to get a knowledge about the lightning discharge, we have to use the C-band antenna. What we did in our observations at MIT main campus, L-band and S-band antenna are working, and one observer was there. They are identifying the lightning discharge. It's about 3 to 42 millisecond duration within that range. So they are identifying the lightning discharge, and that lightning in the electromagnetic radiation when propagating the particular direction, etc. All the properties are taken, and immediately by using another antenna, that observation was done at the Millstone Hill, 42 kilometers away from the main campus of MIT, where C-band antenna is there. There is the largest diameter antenna, global largest diameter, 150 feet diameter of that antenna. So it can receive the signal, and most of the signal. In fact, during 1 year time, we received 92 lightning echoes. Now, you are just recording the signal, that's all. Then at your convenient time, at night in your home, or at any time you like, you can now analyze the data, and then after proper filtering, applying the pattern recognition and all these things, then you can get information about it. What we did, the beauty of our observation was that before our observation, it was predicted that lightning is an underdense plasma. But we, when got a sufficient number of data, then ultimately we were able to establish that if the temperature is 35,000 Kelvin, then below that temperature it is underdense. But if it is above that temperature, 35 to 50,000 Kelvin or even sometimes more, then it will be overdense. So ultimately, the theory of Dawson that was established before and published in Nature, we modified that theory, and ultimately it was also published in some reputed journal that lightning is not the underdense plasma, but in many times it is overdense. In India, there is no C-band radar, unfortunately, but it is too costly, $1 million experiment, even for an hour or so. So, since in tropical countries like India, there is an opportunity to study lightning discharges, which is very much related to electromagnetic wave and many other disturbances in the atmosphere like cyclone, etc., or even during the pre-monsoon thunderstorm, the so-called nor'wester, that occurring in Asansol, Hazaribagh, and coming forward towards the Calcutta within 3 to 4 hours. So there are opportunity to study on it, but still, because of the lack of C-band radar right now, the L-band and S-band radar are working, and we are gathering and collecting information of the electromagnetic signal that is developing from it. But in addition, some additional instruments have been developed in recent years. I will come to those. And those instruments are supplemented by that radar data, can providing valuable information to us, which are helpful. But important is that in USA, lightning discharges are there, while in India or in other tropical countries, and there are frequent occurrences of lightning during March to May, and those are called nor'easter, you know. And June to September, even during the monsoon period, there are huge lightning, particularly at the onset of the monsoon. But we are missing those data because of the improvement of the instrument. Hopefully, it will come in future, in near future maybe, and then some additional information will come. Anyway, these are the radar timing is important. Now, you know, this pulse repetition of the radar system. Um, Pulse repetition is to be considered, and with that, the time period, that means P or T, pulse repetition time, reciprocal of that may be converted for analyzing the system. Then comes the duty cycle, the product of pulse width and pulse repetition frequency is known as the duty cycle. That parameter is also to be taken into account in addition to dwell time. Dwell time means the time that an antenna beam spends on a target. So, because immediately it will return from it, so that time is also equally important, and the time TD is to be analyzed. Now, in radar equation, there are a number of factors because as we have seen from the block diagram and the outline of the instruments, there is a transmitting system, a receiving system. You are sending a signal of certain strength. It will be received by the receiving system, that means the object, and then the dwell time is to be considered. So considering all these different parameters, you can calculate the value of PR, power PR returning to the receiving antenna. That is an important factor where from you can take decision about the signal strength and you can get idea about the electromagnetic waves that is propagating. In doing all these things, one very important parameter is the radar cross-section that depends on certain factors as shown here, 1, 2, 3, 4. These factors are to be considered properly in order to get the idea of radar cross-section, because on the basis of that radar cross-section, you can ultimately go to the radar equation and thereby you can get knowledge about the signal noise, signal transmitting system. Because when you are sending a signal in the form of beam, then if other signal is transmitted simultaneously, then what will happen? Those will interact and overlapping, and because of the overlapping of the system, fading pattern will form. That is unwanted. That problems are to be minimized, if not at all solved. Sometimes it can be solved, otherwise it should be minimized. Then problem comes from clutter are of different types as shown. That is also unwanted to a radar people. And the third one is about clutters are coming from surface clutter, volume clutter, point clutter, etc. I'm not going into the detail. Now, the important thing of physics again comes, that is the Doppler effect. When source stationary, observer moving, both are moving, these are the theories you know behind the Doppler effect, and the Doppler radar in the form of pulse or maybe in the form of continuous signal. These principles are at the background and are to be strictly followed. Now, during the forward and return time, if you find, you can see that in one time, the wave frequency increases, while at the return time, when moving out, then it reduces. And the other problem is about the jamming. Jamming may be because of the, jamming may be in satellite also, equally true for radar. Maybe from other radio sources, signals are transmitting. Now, you have sent your signal from the transmitting antenna, in sometimes in between they are interacting. Maybe through the troposphere, maybe through the ionosphere. If it is through the troposphere, these are, you know, microwave signals. So if it is through the troposphere, then one type of problem will come. While if it goes to the ionosphere and bending, it is coming down towards the receiving system, and another signal from other observatory or from some other sources, any other radio signal, if those are interact, then you can find a fading pattern on the system. What is to be done? For example, during heavy rain, this can be happen. So weather disturbance is another criteria of jamming of the signal. What we have to do, suppose for example the lightning, its electromagnetic signal strength is large compared to the signal strength that is received from the rainfall itself. I should say precipitation. Precipitation is a common word combining rainfall and snowfall. In cold countries, snowfall is the common phenomenon, so we should say precipitation. So from precipitation also the signals are coming, and if you just combine those, then it will be obscured. The information of the electromagnetic signal, for example, due to lightning, will be missing. So what you have to do, you have to, just to filter it, you have to study the signal to noise ratio of both of them, both originating from precipitation as well as that from the lightning discharges. Then once you get an idea of the signal level in decibel, then put the noise level, noise because unwanted signal to me, put it below it. In that way you can filter and put the electromagnetic desired signal at the higher level, so that you can separate the noise from the signal and thereby recording it through the PPI, plant position indicator, and RHI, range height indicator. You can record it, and then at your convenient time you can analyze. But most of the time what happens, for example in airport, pilot is in the aircraft, his information immediately required, so you cannot take much time. For research purpose, it's all right. You can bring it back to your home and you can analyze the data. But for all other practical purposes, the information is to be immediately communicated to the pilot, so that accordingly he can change the decision. For example, if there is a cumulonimbus cloud, cumulonimbus, there are 10 types of clouds, you know, cumulonimbus, nimbus stratus. During the pre-monsoon, the clouds are cumulonimbus. Then altostratus, altocumulus, the top cloud is cirrus, cirrostratus, cirrocumulus, etc. Now, if it is a cumulonimbus type of cloud, then the upper part carry positive charges and lower part carry negative charges. And if the pilot somehow moves within that cloud, it has a vertical height, not horizontal distributed. So if the pilot moves within that cloud, what will happen? There will be disaster. There will be a serious accident. So it's the responsibility of the airport to study through the radar about the height, location, and its movement. Cloud is not at rest. It will move in its own way. It will not follow your order. So the direction of the movement and the possible direction of the movement more specifically, all these are to be measured and studied by the radar immediately and will be communicated to the pilot, so that considering the height where it is moving, it can go up above the cloud, or it can come down, that means below the cloud, for a safety zone. So that is important, and that is done immediately without delay. Say within 2 to 3 second time, it is to be studied, analyzed, and immediately communicated to the pilot, so that there are certain mechanisms so that it can be immediately done, so that he can take the decision, and accordingly he can move either at up or down level. Radar frequencies are mainly in the L, S, and C band, but X band and some other bands, those are also working. Now I am going very quickly about some typical type of radar. One is the air defense radar. Air defense radar is important because enemy locations can be identified with the help of it, and it can observe a distance of about 300 miles today. Initially, it was 250 to 300 kilometers, but now the range has increased. It is up to 300 miles and over 360 degrees. So at any position within the distance of 300 miles, the enemy activities can be identified. So particularly during the battle time, the battlefield, and well in advance, if the information is given, then it becomes extremely helpful. So it is one of the type. The air traffic control radars are of different types, as shown: en route radar systems, air surveillance radar system, precision approach radar system, surface movement radar, and spatial weather radar. Here are some of the types shown. It is en route radar, that is L-band type, low cost, but it is definitely good. It has improved considerably today. Why? Because it can study over the large area up to 250 nautical mile. 1 nautical mile means 1.82 kilometer. In radar or in navigation system, they are not expressed in kilometer or miles, because that creates a problem. What is the problem? Problem is, in India, our system of distance measurement is in kilometer, while in USA, their system of measurement is miles. So let us go to a third system, that is the nautical mile. 1 nautical mile equal to 1.82 kilometer, and that is internationally used. So instead of saying in kilometer or mile, it is expressed in terms of nautical mile. En route radar are of L type, but its beauty is that it can study up to 250 nautical mile, which is significantly large. So it can help during the battlefield in particular. Then there is air surveillance radar. It can altitudes below, that means up to 25,000 feet, in terms of feet, it is expressed, and within 40 to 60 nautical miles, that means 75 to 110 kilometer, it can observe. The system can collect information and immediately it can provide to the person concerned. Then precision approach radar is ground control. The pilot is guided by ground control using this type. The guidance information is obtained by the radar operator and passed to the aircraft by either voice radio or a computer link to the aircraft. It is equally important. Then the surface movement radar, this is particularly important during the time of disturbed weather. During bad weather, you have to locate the positions well in advance and inform to the pilot, so that it can be properly placed on the surface at the time of setting. And the other one is the spatial weather type radar, that is mainly used by India Meteorological for predicting. But it is equally good, because you will agree with me that today the prediction of the meteorological department are more or less accurate. It is not like that in 20 or 30 years back. They are now predicting more or less correctly, and that is helpful for the domestic purposes. I told you about the PPI scope. Here is a sample of PPI. It is rotating within that 360 degree and up to a distance of, say, 300 miles or so. It is collecting information. Once you get the information that something is happening there, there is an obstacle, an obstructing something. If you get an information, we call it target, then set it at that angle, at that particular direction, and collect information more accurately, increasing the resolution power and all the things. Once those informations are collected, what you can do, you can take the decision immediately. A number of people are there in the room. say 15 people are working simultaneously, those data will go to their table. They will collect different informations about it and immediately communicate to the central person, and it will be communicated to the pilot that these are going to happen. So a team is working at the background, radar is collecting the information, and with the support of those information, you can take any decision well in advance that save our life, that helps during the battle with the enemy. So a lot of applications are there. Here is another PPI sample. Some of the applications have shown here. For military applications, I'm not going into detail. Military radars are one of the most important requirements, you believe, that during the wartime. Then here are some of the typical type of applications of radars, particularly in defense field: air defense radar, missile control radar, air traffic control radar, ground surveillance radar, military types. Their technologies, their observing techniques, all are different from one to another. But we are not going into the details. I'm just trying to show you a bird's eye view about all those things. Then remote sensing radar, which is now a very important topic, particularly mapping of sea ice. A lot of works are now being done on it. Then air traffic control radar, they give highest priority to the precipitation when the informations are taken well in advance, and space applications are there also. Then day-to-day applications, some of the day-to-day applications are detonators. Then it can be used as a lifesaver, particularly when during the September 11, 2001 terrorist attack, that lifesaver time helped a lot. And then this is for observing the position of the damaged position of the bridge, may be important for the civil people, and they are also working on it. And, those are under developing conditions. And some of the positive informations have already been received. Just let us go through some photographs. Tunnel wall inspection that can be done, which is not possible by some other alternative means. Then mine inspection, locating underground pipes, again important for the civil people, locating grave. Then here are some of the data of the ionospheric observations by the radar. I was involved with those during that time. So at the very beginning, I told that electrons are there in the ionospheric layer, D layer, and even during the night time, the observation can be received from the E layer. So taking observations of the ionosphere, lot of informations can be obtained, and there are so many applications are there. Now, suppose there is an electromagnetic wave that can be received by sensitive receiver. And when it is received, it is called atmospherics or spherics. Now, in addition to the radar data, because it can provide you an overall impression, overall idea of the system. If you try to go to the fine points of all these things, then you have to study the spherics. Those electromagnetic signals can be received as spherics. Spherics can be received in the VLF band. That means 3 to 30 kilohertz. But it has been seen, we have noted that at 10 kilohertz, it exhibits a peak value. Here is one of the sample of the spherics. Then there is another sample. The first one is called L burst, low burst, while the second one is known as S burst. I will show you some of the audio records also later on. Then what we started to think that if we take the radar observations, then it can provide most of the time, except for navigation purposes, most of the time it can give you an overall impression, and even if it is filtered, then also because of clutter and certain other things, some of the filtering are affected and not good enough. So simultaneously, we have to improve the data, and for that, some electronic typical circuits are made. This is a paper we published at IEEE journal and also asked for patent later on. Some of the electronic circuits were developed. These were developed by me with one of my foreign colleagues. With the support of those data, what we did, we collected the radar data, we collected the spherics data, and in addition, ELF and VLF, as I told you that VLF range, we can record the spherics data, but if we come down to ELF, that means up to 3 kilohertz, then we can get some of the fine informations, particularly informations related to cyclones. We developed this instrument in USA, but we recorded it. The observations are taken in India during the tropical cyclone Rohanu and later on for some other cyclones. What we noted that if the ELF observations are taken in addition to VLF, then during the period of cyclone, it becomes, the signal strength becomes very confined. But before that, well in advance, we can find the variation of the signal strength in the form of L or S burst. So if we get an idea about the direction of the movement of a cyclone, if we get an idea about the vigorous activity of the cyclone, and also about the speed and all other things, as can be simultaneously recorded from satellite data and locally distributed radar data, which is of course not available always, then we can predict more critically about the property of the cyclone, what is going to happen. Sometimes even today, we are in a problem, we cannot predict properly that what will be the position of the landfall of the cyclone. We think that huge money from the government level is used for that, but ultimately we find no, it has changed its track, it has changed its direction, and instead of landfall at Calcutta, it is at Chattogram or some other places at Bangladesh. That happens even in recent time. So here is a problem which is to be solved, at least to some extent, so that unnecessary panic will not come, and we can more confidently set our system, set our people also, so that during this danger time, it can work properly. Here are some of the spectral behavior in ELF, VLF spherics. As I told you, the instruments are developed by me with one of my American friend. He's a military man. In fact, with him, we wrote a book on radio astronomy also from Taylor and Francis. So these are the variational characteristics, as you find that it can be changed from one type to another type if we go to VLF to ELF band, but if it is a continuous one, then we can calculate the average level, plotting all these things, and ultimately at the time of peak activity of this cyclone, it has been noted that those are confined. The signal strength is large, but the variational pattern is not sufficiently large as in the early times. So once those type of behaviors are observed, then we can think about the type of the cyclone and its vigorous activity, and we have calculated it for several times and later on, and those are in good agreement with our technique that we have developed. Now, from these observations, this is a typical observation just I am mentioning here because in addition to radar, simultaneously the radio signal observations, if we take, then it will support a lot in our system, and more confirmedly we can predict about the characteristics and ultimate behavior of the cyclone. That is one of the point. And another point is that if you get an idea of the signal strength, then at the time of communication, you can communicate radio wave signal communication. You can communicate it at a higher level so that it cannot be disturbed. It cannot be obscured. And that is to be maintained properly. Now, I think is it not audible? This is the S burst, not audible. Anyway, I'm going to the L burst system. Yes, it's audible. L burst is audible. Only one was S burst, that was not audible, but the L burst is audible to you. That happens well in advance before the formation of the cyclone. So if you simultaneously with your recording system, if the audio is kept there, then you can get idea about its activity, and activity means activity of the lightning type within it. We know that there are three different types of lightning. One is cloud to ground, then the other one is cloud to air, and the third one is intercloud. If it is cloud to ground type, then the electromagnetic wave signal pattern will be different, and then in order to transmit other signal, we need to obscure the first one. That is for one applications, while when we are thinking about the tropical cyclone, then it can give you a prediction of what is going to happen. Then we are coming to the other type when it is converted to full-fledged. It is a full-fledged cyclone that was recorded it about 3 to 4 hours later. So once you get that type of observations, both audio and video, then you can think about it, and ultimately when the cyclone appears over the station, then the audio will confirm you that it is happening. Now, depending on the type of cyclone or depression, this varies, and if you are an expert, then you can identify from one type to another. So I am now almost at the point of ending of my talk. As I told you, that two distinct areas of contributions are there, and we have implemented the system for some other typical cases, and also from our experience we have improved it, and we'll be able to do it sometimes in near future also. And that is, I think that is all about the presentation. In preparing this PPT, I followed some of my books, one on radio wave propagation, the other one on radar systems and radios to navigation. The third one is a very important book, Emerging Technologies in Applied Sciences and Engineering, covering the different topics. And the fourth one is on robotics, and that is recently written by me. I think that is all about my presentation. Thanks to all of you, and particularly I'm glad that you have listened with your full attention, which is to some extent unbelievable to me, because most of the topics are entirely new to you, most of you. Even that your support was helpful, and thanks to all of you once again, particularly to the persons who are on the dais. Namaskar.
Thank you, sir. Thank you very much for giving us this opportunity to listen in this session on the topic radio technology, radar system, and radio aids navigation system. And sir, I'm sure that all we have enjoyed a lot and got very informations. It was very innovative and very much informative session. And now is the time to show our respect. And I would like to request our Honorable Principal, sir, to present a very small token of respect on behalf of our institution. Thank you, sir. Now is the time for lunch. It's a lunch break. And again, we will be here to start our last part of today's session at 2:45. And it's a half an hour lunch break. So I'd like to request all our beloved students, are you enjoying? I hope you got very much information on this topic. So please complete your lunch. And again, we will meet here at 2:40 p.m. Okay? Thank you, sir. I would like to hand over it to Professor Mohua Datta ma'am.